Hi, this is Algebra 1, Module 7, Lesson 3, Building the Perfect Square. We have quadratic quilts that we're working with here. So Optima has a quilt shop where she sells many colorful quilt blocks for people who want to make their own quilts. She has quilt designs that are made so that they can be sized to fit any bed. She bases her designs on quilt squares that can vary in size. So she calls the length of the side for the basic square x, and the area of the basic square is x squared. In this way, she can customize the designs to make bigger squares or smaller squares. So if she adds 3 inches to each side of the square, what is the area of the square? So here she drew a pattern so we can see what that looks like. So here is our basic x by x square. She added 3 inches, so each of these is 1. Um, if we look at the areas we have here, we have one box that is an x squared, right? We have 3 of these that are an x by 1, which is an x times 1. We have 3 on this side that is an x times 1. And then we have all these little guys that are a 1 by 1. So 1 by 1 is area of 1. So the area of each of these looks like this. We have one of these x squareds. We have 3 here and 3 here, which is a total of 6 x's. And then we have 9 total, just little 1 by 1 squares. So this is one way we can write this out as the area. We also know that we can also write it as this side length times width, which would be x plus 3 squared equals the area. So now for number 2, let me get these out of the way. Use both the diagram and the equation here, x plus 3 squared, to explain why the area of the quilt block square is also equal to this. So these are the two equations we come up with. How can we prove that they are equal? Well, we have two sets of 6x's, right? We have 3 on each side, which makes 6x's total. We have 3 ones on each side, which is 3 times 3, which is 9. And so, which is the same thing as 3 squared, right? And if we think of this mathematically, we can take our x plus 3 times x plus 3, and what we did the other day in our practice problems, wrong direction. Let's undo that. X times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. So that equals x squared plus 6x plus 9, which is the same thing we had up there. So mathematically separating that out, those work. Let's keep going with this. So the customer service rep at Optima's shop work with customers' orders and write up the orders based on the area of the fabric needed for the order. As you can see from problem number 2, there's 2 ways we can call in and describe the area of the quilt. One way describes the length of the sides of the block. The other way describes the areas of each of the 4 sections. So for each of the following quilt blocks, let's draw a diagram, and then we'll write the areas in 2 different ways, kind of what we did before. So if we're going to do these shapes, do these in blue. The length of this would be an x plus 2. So, oh, I don't want a line. Let's do a square on this one. Okay, so I want a kind of a big one like this. And then I'm going to draw, here's my x this way. Get this, there we go. And I need 2 going down this way. And then I need, let me try to make this as close to an x by x square over there. Oop. Work on my accuracy. There we go. And then 2 this way. Oh, that's kind of high. Undo that. Put it just a little bit lower. Okay, so um, that's kind of the idea. Not perfect because it's, well, on a computer. But what we do have is the x and the 2, x and the 2. So the first way we can write it is x plus 2 squared. Or we could say there's 1 x squared. There's 1, 2, 3, 4 x's. And there's 4 little dots, 4 of the 1 by 1s. All right, so then the next one, block with side length x plus 1. I'm going to do it backwards so that I have a little more space here. So we'll make it about this big, nice square. Now we just need 1 tacked onto it. So I'll try to make that as even as possible here. Oh, ah, this is tricky to do on my laptop. Close enough. There we go. And then I need 1 on this side. Oh, almost had it. Just gotta get it over to my line. There. Okay. So here I've got my x and 1, x and 1. So I can do x plus 1 squared, or I could look at the actual areas. I have 1x squared, I have 2 x's, and I have 1 small box. So what patterns do we notice when we relate the diagrams of the two expressions of areas? Well, I notice that I always have 1x squared. So I can type this one in. So 1x squared. I have 2 sets of x's and some number of x's, right? I've got this. I've got 2 sides with the x's, and then I've got some sort of 1 by 1 in there. So when we're looking at this, if we look at we like patterns. If we look at this, what am I doing to this 1 to get a 2? What am I doing this 1 to get a 1? What am I doing with the 2 to get a 4? What am I doing with 2 to get a 4? Those might be able to figure out. I'm going to use the one back here to see a better pattern because I noticed this doubled to get the 6 and I squared it to get the 9. Well, 3 doubled is 6, 3 squared is 9. Let's look on here. 2 doubled is 4, 2 squared is 4. 1 doubled is 2, 1 squared is 1. So I could say x plus h squared is x squared, because we ended up with an x squared, plus 2 h's for my x, right? Twice as many to get there, plus h squared for my c. So I kind of found a pattern with that. Optima likes to have her little dog Clementine around the shop. One day the dog got a little hungry and started to chew up orders. When Optima found the orders, one of them was so chewed up that there were only partial expressions for the areas remaining. Help Optima by completing each of the following expressions for the areas that describe a perfect square. Then write 2 equivalent equations. So we call this a perfect square, right? It makes a perfect square block. So if I notice that this is twice as much as my h, and then if I square it, I get my c. I need to find c, right? Well, b here, if that's 2h, then 4 divided by 2 gets me 2, which equals h. So then h squared equals c, 2 squared equals 4. So that means x plus my h, which is 2 squared, is going to equal x squared plus 4x right here, plus c, which is 2 squared, which is 4. Let's look at the next one. 6x. Well, again, if I need to split it in half to get my h, then I'm going to do 6 divided by 2 equals 3. So 3 equals h. H squared is c. So 3 squared is 9. So going to my equation, x plus h is 3 squared equals x squared plus 6x, that's what I've got going on here, plus c, which is 3 squared, which is 9. All right, let's look at the next ones. Okay, so here I've got an 8. So if I do 8 divided by 2 equals 4, which equals h. So c equals 4 squared, which is 16. So that means I have x plus h, which is 4 squared. And if I write that in standard form, x squared plus 8x, right? We already have that, plus 16, because that's what 4 squared is. Next one. Here, 12x. So 12 divided by 2 equals 6. So that's my h. C equals my h squared. So 6 squared is 36. So that means my equation is x plus 6, which is my h. And then when I want to complete it over here, x squared plus 12x plus 6 squared is 36. Okay, so if x squared plus bx plus c is a perfect square, what's the relationship between b and c? How to use b to find c? Well, what we did every time was we split it in half and then squared it, right? So b split in half squared equals c. So let's put that in words next to it. Split b in half and square it to find c. All right, will this work if b is negative? Why or why not? Well, let's try it. Let's do x squared minus, we'll do 8x and see if we can complete that. All right, so let's plug it into this equation right here. Negative 8, cut it in half, and then square it. Well, negative 8 divided by 2 is negative 4. So negative 4 squared is 16. So that means when we complete it, minus 8x plus 16. So yes, b is just negative. Doesn't do any difference, right? Because when we square it, we still end up with a positive number. Okay, does it work if it's an odd number? Well, let's try it. X squared plus 5. We want to complete this, right? So let's plug it in. 5 divided by 2 squared. Well, half of 5 is 2.5 squared is 6.25. So does it work? Yes. C is just a decimal. So it does work. All right. That's it for this one. Thanks for joining us. We'll see you next time.